A massive humpback whale hears the screams of a dying seal and swims miles directly toward the danger. Instead of fleeing the ocean's apex predators, these giants risk fatal injury to shield total strangers from an orca's jaws. Is this a calculated evolutionary grudge, or have we finally discovered true empathy in the deep? Nature operates on a tight energy budget. For a giant to expend calories protecting an unrelated species contradicts the logic of self-preservation. A whale has no direct biological reason to care about the survival of a seal. Yet when the attack begins, a humpback accelerates its 40-ton body to urgently intercept the hunt. They charge directly into the kill zone. This deliberate behavioral pattern has been documented enough to force a reassessment of how ocean hierarchies actually operate. Modern acoustic research and tracking data allow scientists to detect the specific distress frequencies of a hunt across vast ocean distances. This acoustic monitoring provided the foundation for a 2016 NOAA dataset, which compiled 115 documented interactions between humpbacks and killer whales. This chart shows the 115 interactions recorded in the dataset. It reveals that humpback whales are not accidental bystanders. They actively initiate 57% of these clashes. They engage in mobbing behavior. The humpbacks seek out the kill zone and use their massive size to physically disrupt the predators, forcing them to abandon the hunt. These records shift the profile of the humpback. They are active, aggressive instigators, policing the waters. Leaving a feeding ground to fight requires an immense caloric cost. A humpback travels miles, burning energy reserves, engaging in a conflict that provides no nutritional reward. And the danger is severe. Intercepting a hunt exposes the humpback to vicious counterattacks from a highly coordinated group of orcas. The biological consequences of these violent clashes include massive blood loss, deep flesh wounds, and even permanent fin damage. A humpback endures these heavy physical tolls while gaining 0 calories or survival benefits from the random seal they manage to save. This behavior actively harms the individual whale. It violates the foundational rules of biological economics, where every single action should improve an animal's overall chances of survival. The specific target of the humpback's aggression reveals the underlying driver. Clashes involve mammal-eating killer whales, or mecways, 95% of the time. The humpbacks completely ignore the pods that eat fish. This diagram visualizes the threat these specific pods pose. When mecways approach humpbacks, they initiate an attack 85% of the time. As the graphic identifies the target of those attacks, we see killer whales bypass adults to exclusively hunt the vulnerable young. Over time, an evolutionary adaptation emerged. Humpback mothers developed a hyper-aggressive preemptive mobbing response, specifically to ensure their calves survive an encounter. Fascinated, biologists call the resulting behavior a kin selection glitch. This maternal defense programming triggers automatically whenever the humpback hears mechs attacking any animal. What appears to be calculated heroic altruism is a maternal survival mechanism misfiring across species lines. We see similar biological programming in land mammals, where neurological defense systems bridge species gaps, such as a dog adopting an orphaned kitten. In the ocean, this glitch scales up into something ecologists call behavioral jurisprudence. Reacting to their own instincts, apex species inadvertently establish rules of engagement within their habitats. The relentless mobbing by humpbacks actively suppresses MEKW hunting success, creating an unintended protective umbrella for seals and other prey sharing the same waters. Regardless of their initial biological intent, humpbacks effectively operate as the ocean's enforcers. They maintain ecological balance by continually checking the power of dominant predators. This intervention challenges the classic selfish gene model, which argues that all animal behavior must serve direct genetic replication. We are left to wonder if this is purely an evolutionary grudge against calf killers, or if the glitch has evolved into a genuine display of interspecies empathy. That lingering mystery cements the humpback whale as the ocean's most complex and mysterious guardian. Investigate the biological mechanics that define our oceans. Click the subscribe button, activate the bell, and join us for the next scientific investigation beyond the boundaries of reason, only on TEMBODocs.